home. Hello, Edgar. Hello, Ali, Alfonso, Isaac, Sabrina, Joel, Micho, Chandler, Ted, Mingo, Kevin. Hello, how are we doing? Hello, Harry. Oh, Harry's here today. Wilfredo, yeah, how are we doing? Are you looking for teammates, Will? I just saw your post on Ireland, right? Um, who in our class right now already has a team? Who has already has a team? Please give a green dot, please. Who in the room has a team, please? Right? I've been working with all the teams, updating posts on Island, right? Answering your email. It's a lot of fun. And a couple of teams already started having their meetings. One team actually, I think, have a second meeting. That is awesome, right? And the minimum we want is about three meetings, and one team already got two meetings out, so that is wonderful. Okay, all right, let's see. Almost all of us here got a team. Some of the classmates here who are not answering, but I know you have a team. Okay, maybe there's no yes button on your interface or something. Okay. If you still need a team, the easiest way, right, is to look to go on Island. Our classmate has been very active, right? We already have all the teams starting on the top and at the bottom here. I've been monitoring the conversation there, right? The classmate who look for teammates and already found one, I mark that as close, right? And all the teams that are ready to work, I mark them and pin them on top as Fantastic Five. We have some great names, everybody. We have some great names for teams, very creative. I'm happy that the sense of humor is still there, the fun is still there. So that is awesome, and there's no better way to wrap up the last weeks of class than this. And I really hope that you enjoy working with each other, learn from it. That's most important. In this case, this is more like a easy credit opportunity. But think of it as if you go to work, how much different it's gonna be, right? The team dynamic, the organizational dynamic is always one of the most difficult thing. Doesn't matter what field you are going into, right? So always learn, working with other people. That's the most important part there. On the weekend, let's see what happened on the weekend. Besides, working with our classmate, creating teams and all, um, I post some good articles for you to read. There's one that has been out from last week, and I actually was discussing with, I think, the toe or tick section or tag section, that Google is offering 100,000 scholarships, right? This is where they respond to the low unemployment, high unemployment rate of our nation right now. They create 100,000 scholarship. If you get the scholarship, you get a certifications that is equivalent to when you finish the training. You get a certification that is equivalent to a 4 year bachelor degree in computer science, in data analytics, in project management, in user experience. Right? Is Where's our Mr. UX? Where is he? Is Jay here? Is Jay here? Is Jay here? He So you want to explore all of this, everybody? Yeah, here's a chance for you, Jay. Right? So working with Google, getting certification, getting job, right? UX, experience right there. So please explore all of that out, everybody. I actually share with you all the articles on week number 8 on the file manager. You may notice that I post, I constantly post really good articles for you, mostly about job and organizational behavior, and some technical stuff on file manager when you have time to read. I also post for you the an article about how to nail a job interview remotely, right? Something that is very beneficial during this time. Um, Also, I'm working with our department, and there's one institute that is approaching us looking for student advocate, right? And they have a scholarship, and this is for the Hispanics group. So if you're a Hispanic student in the class, if you're doing well, if you want to get involved, please, contact me as soon as possible, right? They want to give you opportunity to lead, and they want to give you 1,500 uh, dollars for this year, and also opportunities to network with other people, going to conferences in September. Maybe it's a remote conference this time. So please contact me as soon as possible. What else going on here? Transfer student on Friday. Thank you again, our classmate who volunteer to help the department to welcome 550 students. Everybody, that's what we are getting in the fall, right? Freshmen and transfer student, 550. Imagine 550 people are new to our department coming in this August. And, I've been meeting with them every week, right? Not all of them, but group by group. And some of them still don't know what their SFSU ID is, what's their email is. How can they be ready for the fall semester? They really need help, right? They really need help. Even for us, everyone, make sure that you check your accepted email regularly, right? Because one simple question on Monday in August, first day of class, right? Where are you going for your class, right? For your classes, right? You need to be in touch with your new professors for your new classes, knowing where to go, where is the Zoom links, right? And not all professors are early. If they don't contact you, you may want to look on Island. They may want to send them email, or even go to their department, if not computer science. Say, where is my class? Where is my class so that I can go to when I wake up and hurry in the morning. August. When do we start class in August? Everybody, anybody look at the schedule yet? August 20 something. Okay, other than that, that all the news I have for us today. Any questions for me? I hope August 23rd, 24th, right? Yeah, okay. So make sure, right, you write out, okay? You want to contact your professor as soon as possible. Because what happens if you don't show up on the first day of class, everybody? You may lose your seat, right? That is a problem. And so a lot of people are trying to get in. So make sure that, you stay on top of that. I hope you had a very good weekend, right? I had a good weekend. One of the things I did was building a secret path for my cat to enter the house, because there have been more and more coyotes, around the street, and I don't want my cat to become dinner. So I finished the project, a secret path to enter the house. So that was good. Yeah. Um, I know. Have you seen those coyote guys? I saw some beautiful, lean, beautiful coyotes, and they are smart. I live near school, right? Toward the Slot Avenue. Sometime, I take a walk and I see them actually stop at the red line. Okay, there's traffic lights. They stop when it's green. They pass the street. I was like, wow, that's pretty impressive. You know, they do that. Yeah, yeah, coyote. Yeah, big ones. More coyotes, more animals actually roaming around during this COVID-19 time. Talking about COVID-19, a lot of news this morning, right? Big pharmaceutical company are releasing news about their progress on the vaccine. Russia declared that they already have the vaccine for COVID-19 25 years ago, right? They just haven't tested and now they start using it. They said they have the formula of 25 years ago. So now the big question is two big questions we have about vaccine. Number one, right? There will not be one company that can produce enough vaccine for the whole world, right? So how is that going to be done? The second question is that vaccine usually takes at least 2 years, right? At least 2 years for all the testing and this and that. And now it's less than a year. Let's say that at the end of this December, we have vaccine coming out. Would you take it? Would you take it? Right? Would you take it? That's a big question right now, right? So they are all fighting, trying to have vaccine, but would you take it? That's the question right now. All right, that's enough for the news. If you have any question, please let me know. Let's look at our progress, everybody. So, if you have any question about the assignment 3 preparation, please let me know. But again, it's very clear that we learn Linglish, right, and recursion in Java, and I gave you the C++ version. I gave you about 39 diagrams, right? All the demonstration how each line number of the link back package works, right? I gave you all the answers for the recursion package. So you just have to read it, understand it, and prepare. And that's gonna be the greatest support that you can have for assignment 3. Three topics for assignment 3. Number 1, smart pointers. Number two, link back. And number 3, recursion. You don't have to go in order, right? And this week, we're going to finish smart pointers. Smart pointer is the first question, and also one question in the later part, right? And we're going to go through that this week, okay? Um, I'm really tight on time right now, but if you can, um, I don't know how to say this. What I mean here is that I'm trying to go to your team meetings, if possible. That's what I'm looking for. Okay, so if you let me know, right, that you're meeting and you are really meeting on that time, I will try to come if that helps. Okay, and of course in class we're gonna go through the packages together as well. Right? I mean we don't have that much time to go through, slowly, but with the teamwork and in class, we're gonna get it done very well. All right. So package number 7256, everybody. When you're ready to learn, give me a green dot, okay? And I will give you a quick recap of what happened last week, and then we move on. All right. So that was a quick, 7 minutes news. So let's move on now. Let's Here we go. Did I miss any news? Did I miss any news? News is important. All right. Okay. Uh, this 340. Oh wait, 340. And this is week 7. Who's ready? Who's ready? This is week 8 already, everybody. Welcome to week 8. We're almost there. And we are working on package number 7, text section, right? And we are on line number, did I say 256? So 256. Oh, that's a great page. 256. Okay. So let me take you back about 2 or 3 pages and describe to you again what happened last time, right? So now, first of all, what we did was this, everyone. Let me take you about 3 pages back, okay? 3 pages back. And here we go. So, first of all, we talk about, how about one more? On line number 112, right? That's an important one line here. That's where we talk about if we see a pointer in C++, right? Never assume that is, one single entry object. We don't know if that could be an array, right? And that's what we explore, and that I use that as one easy, demonstration for us to test the big five. What's the difference between the copy and the move constructor and assignment operators, everybody? Whenever we see the keyword move, we know that is that modern or classic C++. Whenever we see the keyword move, we know is that modern or traditional. It's modern C++, right? The copy constructor was actually what we learned in Java. Everybody remember when we talk about deep copy and shallow copy, right? And the idea of copy assignment operator basically here is that we are overloading the operator so it can do more for us, right? And destructor is a function to clean up our object, right? When we want it to go out of scope or we want to call a delete on it, right? So, and then whenever we see a move, that means we should expect an R value on the right side, right? Either for move constructor or move assignment operator. Whenever we see a copy, that's when we are expecting an L value on the right side. This is why back to package number 5, we don't want to call them right-handed value or left-handed value because we can have here both L and R values on the right side, right? So last week we discussed, very, very important concept. Whenever we see the keyword constructor, we know that we are creating something new, right? Whenever we see constructor, we know that we are creating something new. Whenever we see that we see an assignment operator, means what? We are having two existing objects and we use one to copy over the other. Are we all clear about those big five, everybody? What they are at least, right? And the service that they provide. Any question here? Okay. And then we talk about what? We talk about the ISO, right? International Standard Organization for C++. They just say, well, by default, big C++ give you the big five. They work or not? Do they? If they work the way you want or not? That's not our business, right? That's your responsibility as a programmer. In the programmer community, we all understand that most of the time the big five do not work, right? And more important, if we ever override one of those big five, we have to write all of them, all the five. So those are the rules, right? And then last week, we went on and we explore how they work using this simple example of a computer science student who's supposed to read 50 books a semester. And I'm happy that we are all doing that, right? Most of us are on book number 51, right? So we did 5 tests, yeah. So test number 1, right? We see that the default copy constructor that did not work, right? The default copy constructor did not work. The default copy assignment operator did not work, right? The next one on test number 3, what we test was the default move constructor. We had no idea, if it was working or not. And most importantly, the goal that we are aiming for the modern C++ here is to optimize the memory. And there's not enough information for us to know whether the memory being optimized correctly or not. And when we don't know, right? When we don't know, that's when we have to write our own code. We cannot just, depend on what's given because that's very random, right? Very unpredicted. The same situation with the default move assignment operator. We don't know. It's totally unknown. And especially when we get to line number 186 with the default instructor, we did not see any communication from the default instructor. So there's a big don't know right there, right? So out of those five, we see that number one, there's no one successful one, and number two, that there is a need to override all of them. So we know the situation, right? We know the situation. We know our mission. Our mission is that we want to write our own big five in a way that to achieve the best memory management and memory optimization. How are we going to execute that? In order to execute that, we want to know what method is good, right, for the modern memory management. And after that, it's just a matter of administering and communicating, and control the process. And that's what the programming methodology is about. And learning programming methodology, communication, and controlling the process is so important. And that's what we are learning in assignment. It's just assignment 3 preparation. When we do assignment 3 preparation, I urge you to recall what we saw the team IDEO did, right, and compare with what you're doing. and take a step back and look at the team dynamic, right? And see and try to think, it is like this right now. What is it going to be when I go out to work, right? There's a lot of things that you can observe and try to, always pay attention to details. You want to learn a lot whenever you work with another person, okay? You will have some groups that um, could be very stressful, but you end up getting a lot of work done, and you may find some, good friends to continue working even after this project. You may find some group that very enjoying having fun all the time and may not get much work done. But at the same time, you can have a group that totally fun, totally very effective, and you probably is gonna bond with that group and stay with each other for a long time, right? So there's all kind of scenarios can happen when you work with people, right? People is always the most interesting subject out there, right? Okay, so on the next page, right? On the next page, what I gave you was that before we start building the big five ourselves, we want to see the tools that we have in hand, right? So first of all, I gave you number one is that in modern C++, we want to avoid all the macro because they don't do anything good except one situation when we can print out the label of all the variables that we are using, right? Any label. And that is, very helpful when we do debugging. Some of us going to pick up a job as quality assurance right after graduation, and this is what you want to use, right? In Java, we have what we have assertion. In Java and C++, we have all those if-else statement. We have all those exception handling. But being able to print out the label can save you a lot of time in especially in tracing value, and all the data flow. Then where we stopped last time were a most important point, right? So let me kind of erase this and explain it again for you, okay? The most important point here is that we compare three different ways to move the data from one object owner to another, right? So the two things that we focus on, right, was what? Number one, we focus on the amount of memory, right, that we are using. And number two is the number of operations, right? So the first one, we call that the copy semantic. And that is a traditional, the basic C++. And then we have the move one, right? Move one and then move two, right? The basic move and the advanced move. And move, why move? Move because behind the swap, right? Behind the swap function of C++, move is used to make it possible. So with the copy, what we see that if we start out with having A and B vectors, and we say, I want to move all the data from vector A to vector B, right? What C++ does is what? Number one, in terms of memory, it's used twice as much of memory because at the end here, at the result, if we start out here having one copy of the data at memory location 770, and after the copying, we end up having two copies of the same data at the two different memory addresses. So the amount of memory is twice, right? And we notice here is that we are moving the same set of data from one vector to another, and we had to go through, each entry in order to make all the copies. And if there are n entries, it takes n operation, right? So we're gonna see that this is the worst, in the among the three. So for the memory and operation for the second one, what happened is that if we copy content from C to D, right, we see that C will be empty after that. That means we maintain only one copy, right, from the beginning to the end of the operation. How many copying operation did we use? We still have to copy, each of the entry from one vector to another, and that takes an operation. So we did better in terms of memory, but operation is still the same, right? The same number of operation. For the last one, we noticed that we had all the data at memory 978, and after the move, right, the data still stay at the same place. So we did not move the data at all. We did not move the data at all. Zero operation, right? How much of memory did we use? There's only one copy. So that is the minimum number amount of memory that we use. So for the memory is the best, right? And operation the best. But we cannot get things done if we did not do anything at all. At the end of package number 5, right, I introduce you the move operation. We talk about the move changing the data from L value to R value, or the other way around. And there's a paragraph there. I describe why move is really the essence, the core of modern C++. And here you can see it. What really happened was that we did use one operation, and that one operation was just to switch the owner of the data, right? So the owner is a big keyword here, but if you want to look into the syntax, you see that simply here is that we start out having a pointer, right? And that is the pointer for the vector owning the data. So at first 978 was owned by E, but at the end, as a result, right, 978 was owned by F. And that's all we did. That's all we did, right? That's all we did. We did not have to. Change the memory location where we store the data. We did not have to make any movement of the data at all. We just basically moved the pointer, right? We basically moved the owner. Doesn't the pointer take up memory too? The pointer, right? Every pointer. So if we say pointer E, right, and we start out, how much memory does it take, Tony? At first, how much memory does it take for the value of the pointer E? How much does it take? It store what? That's right, Jay. It store a memory address, so it's 4 bytes. And you just exchange, saying at first you use 4 bytes to store this address, and after E just take that same 4 bytes, right, to store the other address. So there was, if you want to look, even into the size of the pointer, there's no change at all. There's no change at all. It's only swapping the value. That's it. Just only one move of the pointer and everything is done. And this is very important to grab. We need to understand this concept right away. And now we're going to go into implementing the big 5. And then after that, we need to move to smart pointer. Okay. And what we are doing right now, going to prepare for smart pointer. If we don't understand these points, if we don't understand big 5, going to smart pointer, we will be very lost. Okay. So are we okay to move on to the next page? And we're going to implement big 5s together. Everybody's ready here? It's very interesting, everyone. Okay, who's ready for the next page here? Can we just change the label somehow? Why would we want to change the label, Harry? If you change the label, you just give it a new name, right? And a new name not going to give us, any data movement. Can we change E to F and F to E? We are not changing the label, right? We are swapping the pointer. This is the same as swap number 4 in our package number 5. So that is the foundation we are using, to understand this page. When you are talking about one amount of memory, doesn't it have 2 pointers so we can have 3? Tony, when we talk about the memory, we talk about the memory we use to store the data over here, Tony, right? So if Tony has a question, probably other classmate may have the same question. All right. So let me go back here a little bit, everybody, if you don't mind. So if you look at this, Tony, right, you just focus on the last column on the right side, right? This is the, for example, you use, an X amount of memory to store, two, 0, 2, 4, and 8, 4 and 6, right? Are we all, are you good here, Tony? Right? And that X amount was at memory, 770. Are we all good? In the old copy semantic, right? That same X amount is still over here. Yeah. And then if we want to move the data to a new location, we have to make copy. So it becomes 2x. And that's double the amount of memory for the data. Okay. The pointer is different. The pointer are over here on the left side, right? If you have a pointer to the data, that's totally different from, from the, so this is the memory, right? If you have a pointer here, it is 4 bytes, right? On memory here for the object, it can be as much as you need. So we are talking about this memory, right? And that is the memory we talk about on the right side here, Tony. Okay. And then here, if you make a copy, obviously you are using twice as much, right? Just same as in the deep copy. Are we all good here? And over here, in this case, it is a deep copy. However, you use only, half that amount of memory, right? But you still move from one place to the other. For the last one, you use only one, half the amount of memory, and you still keep it at the same place, 978. And that's why it's so advanced. And the only thing that we changed was on the left side. And that left side, we did not even change the amount of memory. We only changed the content that the pointer is storing, saying, where are you pointing at, right? What object are you owning? And that's all. Are we all good here, Tony? Did you get the concept here? You got it? All right. That's great. Okay. As we do the next page, you will understand it better, Tony. All right. So now, So now on the next page, everybody, this is one example that you want to understand really well, because no class, that we create going to be the same. It's more important to understand how we do it rather than just remember one example. Okay. So this example give you the how, not, what to do step by step. Memorizing not going to help us. That's why I keep, talking about problem solving. So in this case, we understand very well now the situation that we need to, make our own big five. They did not work, right? Our mission is to use the best semantic in this way. So we have three options, right? The old copy semantics, move one and move two. Obviously, move two is a choice, right? If we can. Execution, that's mean now we're going to write the code, right? Okay, so now let's see how we do it. We see the 5 element here, everybody. If you go to an exam or an interview, if you know how to write copy constructors, right, it probably takes about 10 minutes. If you don't know, it may take more than an hour and it's still not done. Okay, so that's how it is. In C++, a lot about you know or you don't know, and the rest is experience. So the copy constructor, let's mark it as the first function that we aim to write. And that was on line number 271. On line number 282, right, it is a second element, right, that we are second function that we aim to write. On line number 299 is the third one. On line number 319, right, that is the fourth one. And the destructor is the last one, right? So 5 of them. The problem with big 5 is this, everyone. Most of the time, when asked to write the big 5, people jump in and start writing right away. The problem with that is that they lost the S right away. They totally lost the situation. That means they don't know what the problem is. They don't know what the problem is. And they end up, not being able to write the big 5, or they write the big 5 that do not work together, right? So S here is so important. S is to know what is the problem, and S is to, make those big 5 work together. That's why we always need to take a step back. So when you write a big five, right, from textbook and from my experience, I would suggest that we spend most of the time on the big zero. That's what it is, because the big zero gives you the situation. The big zero is the most important one, and that is the constructor. That's where you start with, because the constructor, right? Besides the code of the class, the constructor tell you where the problem is. So if we look at the constructor, right, we see this whenever we construct a student object. What are the properties that we need to take care of? On the very top, right? This is super, because we learn the initializer list. We see that, well, very quick, before we even enter the body of the constructor, we were able to take care of the student name. We were able to take care of the number of recommended books right away. So two of that out of the way, right? Two properties out of the way. And then the third one, the number of books also is the third one. It's an integer out of the way. And there's only one problem here, right? That is the that is the fourth property. And because it is an independent object, right? And we already investigate, two pages earlier when we did the experiment with the five big five, the default ones, and how it did not work. So understand the problem and see that for the big five, when we write them, this is where we want to pay attention, right? This is what the problem is. Okay, so we know the problem, we can define the problem, and now we start solving. So knowing zero gonna allow you to write one, and once you can write one, most of it is just copy and paste the same code with changing a little bit. That's why you can write all of this in 10 minutes, right? So now copy constructor means what? Copy constructor means to construct something, to create something new, right? Using something existing. All right. So we got to know what we are doing first. Well, if you are using something new, that means you are using one existing object. If you are using one existing object, we just learned from package number 6, we got to put explicit there right away in order to avoid the what, the implicit type conversion, right? That was line number 15, right? And then we walk all the way down to line number 73 of package number 6. We talk about this. So now, what is that one argument that we pass to this constructor? That is student. And we are passing student by what? We are passing by student by constant reference, right? Because we are using this existing L value object for read only. We are making a copy of that object. So that makes total sense here. Again, this is package number 5, right? So now, how do we make use of a L value object that being passed for us for read only purpose? We use an initializer list. We know that we can three property easily. So let's get that done right away. 1, 2, and 3. We extract the name from the student and we gather, right? Name gather. We extract the number of books from the student number of books gather. We extract the number of recommended book from student get recommended book gather. And now we get to the business right away. This is the core. This is where it's most important. And we said the problem I identify on line number 268 was that the book needs each student needs to have their own bookshelf, right? The books array. So now I'm going to create a bookshelf for this new student so that I will not end up with a mixed copy, right? With a bookshelf being a shallow copy, and that's going to create the conflict. So how do I do that? On line number 276, right? If I copy the deep copy successful for all the three elements on line number 273 and 272, right? Over here, I need to create, a new entire object for my bookshelf. And that is by using new and put that on area 3. Once I have the bookshelf, right, I just have to copy, each element over. Are we all good, right? And the trick here is that when we are creating the array on line number 276, we want to take advantage of the number of recommended book, right? and that is the size of the array that we're going to use to store all the books. Otherwise, we're going to get into big problem with shrinking and expanding the array, and that's it. So that's all we need to write for the constructor, and there's only one line to solve the problem, and that's the most important line, right? So we identify the problem, we see it, we can solve it. So now copy constructor is done, right? We're gonna move to move constructor. Are we all good? So copy constructor means to construct something using something existing. So move constructor means, to create something using something existing but temporary. That means it's soon to be gone. It's an R value. Any question about copy constructor before I move on to move constructor? What does the new string num recommended do, right? What does it do here, everybody? What does this syntax do for us? Jay is asking. Creating a new bookshelf, right? This is the array syntax, Jay, right? This is a array syntax. Does it make sense now? Right? Creating the new bookshelf, creating the new array books for us. Okay. That's right. That's right, Kevin. Very good. Helping classmate here. So now we start to see, before we do we create the move constructor, everybody. It's very important that we got to take a step back and see, number one, what is the difference between a copy constructor and move constructor. Number two, right? Can I apply swap number two here? What can I use? So the wonderful thing about R value is this. So R value, right, is an object, a temporary object that's soon to be gone, and we can destroy that object. If we are going to destroy this object, right, that means what? We don't have to worry about the integrity of the object. Feel free to change it and use any part of it, right, for your purpose, as far as you can manage your memory and optimize your memory. And this is what we did not think of in package number 5 yet, right? Because package number 5 was all about understanding the concept first. So now let's use the beauty of R value, right? So now on line number 283, we notice that if we have the move constructor with one argument, a student, right, an R value, we have to put an explicit right there. However, we don't want to make it constant here, everybody, because we want to change the R value object so that we can achieve the best optimization for our memory. How do we do that? So now let's always take care of easy things first, right? For the 3 parameter, we're going to extract right away from the student, right? We get the name, we get the number of books, we get the recommended right away. So we are done with that. So now we get to the main point. We get to the main point, which has been what? Line number 268, right? And then line number 276. We get to the main point here by saying, all I need to do is just to call a swap. And that's done for the move constructor, if we know how to do it, right? The rest here, where I comment out, is to give you another, alternative if you want to do it manually. What's happening here? If you don't want to use a swap, right? If we don't understand what is happening behind swap, move number 2, we need to take 2 steps. Number 1, we said, if currently, I'm having a bookshelf, I got to delete that entire bookshelf. And then I make a new bookshelf, right? And then I use, swap number 1 to copy all the books over to my bookshelf. And then after that, I delete the object on the right side. Takes a lot of step, a lot of code, and actually doesn't achieve, the best optimization if we go this way. But one line of code that get is totally done. And this is what they want you to write when it comes to the interview, right? They want you to get it done in 10 minutes. They want you to write one line of code rather than writing how many lines here? 2, 4, 6, 7 lines of code, and still doesn't achieve a good result. So what's really happening in this case, everybody? What's really happening on line number 288? Anybody can explain here, as we learned from the last page already. What are we learning here? What are we doing on line number 288? The most important line. And we're going to need this for assignment 3, right? Okay, so what are we doing here on line number 288, everybody? What are we doing? What are we doing in this case? What are we doing here? What we are doing here is this. What we are doing here is this. Let me explain to you, yeah? We have this R value object, right? And if we are creating, right, we are creating the new object over here, right? So what we learned from the last page is that with the move semantics, we never want to use more memory, right? Or we don't want to do all the movement if that's not necessary. And in this case, the goal is this. The goal is to, for the new object, to have a bookshelf, right? And that bookshelf should be the same as the bookshelf of the R value object, right? So that is the goal. Everyone is with me here before I analyze what's happening, right? So this is a goal on the left side, that we want to create that blue and new object. And on the right side, the object is to be deleted. But we take a step back and we say, oh, wait, this is an R value object, right? This is an R value object. This object, entire object, is soon to be destroyed. And that also means I can do anything to the content of the object, and the rest doesn't matter. What do I mean by that? What I mean by that is that there's no need. There's no need to create this blue bookshelf at all. There's no need to create that blue bookshelf, right? All we need to do is to detach the bookshelf, the red bookshelf, from the R value object and give it to the new object, and we are done. We do not need to create, a new bookshelf, and we do not need to move any books over. We don't do any of that. We just take the bookshelf from the object that is soon to be deleted and give it to the new object. As far as we can detach that bookshelf, as far as we can give it to the new one. And when we delete the R value object, we don't delete that bookshelf. Then, mission accomplished. Are we all good here? Everybody understand what's going on here? Right? Very clean, very fast. Very clean, very fast, right? And the best memory management and the best memory optimization you can achieve right here. Any question here, everybody? Any question here? Any question? This is what you want to look at. This is what you want to investigate when you do assignment 3, right? So for assignment 3, same as every other assignment, I want to make it doable, all right, to everybody. That's why I never wrote, any requirement that it has to be, this, it has to be that, in terms of memory and optimization. You can get it done at the speed of 210 and 220 in terms of memory. But if you are really, passionate about this topic, if you really want to prepare yourself for a good job, you want to take assignment 3 to the best level that you can and apply everything we learned from the package. Are we all good? So what I'm saying here is that there's no pressure about being able to complete the assignment, getting an A, right? It's just all about how much more that we want to learn ourselves. And if the way to learn more is that look into the package and say, I'm going to apply this technique so that, I can prepare myself for a job, right? When I go out there, it's not about the grade anymore. It's about, how much I can do for my employer, okay? So now, if this one is still not clear to you, right? How about this? Can I have some confirmation about the point that I was drawing here? How many of us understood this before I move on to the next one? How many of us understood this, please? Can I have some confirmation, please? Oh, a very good numbers. Okay. So you probably were taking note, right? So seems to be quiet. All right. We're gonna run the demo, right? We still have 3 more to write, and I'm gonna explain this again and again. Okay. We're gonna run the demo, and we're gonna analyze the demo 3 times. So you have a lot of chance to learn what we are learning here. No problem at all. Let's move to item number 3, right? So you see there that I rank from 0 to 5, from easy to more difficult, right? As far as we understand 0, we understand 1. We understand 1, we were able to write 2, right? So now we understand 2, we're gonna write 3. How do we do that? So if 1 and 2 is about creating an object from using an existing object, 3 is about what? 3 is about if you are having 2 existing objects and you want to copy one object, over another object. So okay, the simplest thing we have to think of is what? If you have A and B existing and you want to copy B over A, right? But what if they give you A and ask you to copy A over A? Would you do that? Yes, the operator is overloaded, Jay, right? Would you do this, everybody? Would you copy A over A? Who say no, who say yes? Would you copy A over A if they ask you? And you are trying to save memory, you're trying to save operation here. Of course, no, right? Of course, no. In an interview, if they ask us to write, to copy A over A, and if we go do it, no, do you have any other question for my company? And that's done, right? So we at least have to check for this situation. We have to check for this situation. We're gonna say that if you are asking me to copy A over A, right, then I will not do anything in this if statement. Are we all good, right? We are saying that if this object is the same as the object that you are giving in to me, right? You are giving it to this function. I will not do the copy. I will just simply return A to you. Everybody's good here, right? So now, if it's not AA and it is B over A, what do we do? Let me go back from the beginning and explain to you. On line number 300, right? If we want to overload an operator in C++, this is what we do. We say operator, right? And then we write the operator there. Are we all good? Let me don't confuse you. Let me use an arrow here. We write the operator there. And of course, right, we're going to return a reference to the object of the same type. And we are receiving an object of the same type, the same as the previous two. If it's the same as previous two, we know that we want to take care of easy things first. So we are done right away with the 3, simple operation to extract the name, extract the number of books, extract the number of recommended, books to read, and we copy over to this new item. So it's the same, exactly same thing, right? If we are copying over, right, and if we having a bookshelf existing, we want to delete that bookshelf. The easiest way to deal with an array, right? We don't want to move things around. We don't want to expand. You don't want to, shrink it. If you have an array and you need to update it, and the size might be different, just delete it. So I want to call your attention to the syntax here. Whenever we try to delete an array of item, make sure that we do not just call delete. We have to say a deep delete. Okay, this is called a deep delete, everybody. You have to say, you have to put the opening and closing square bracket there, saying that I want to go into that array, follow each entry, and delete those entries. If we just call a delete on an array, it only deletes the container. It doesn't delete the content. We cannot always think of contents being, a few integer numbers. What if, those are pointers, right, to multiple objects and multiple layers? So please pay attention to this one. This is for deleting entire array of objects. Okay, all the objects inside the array. And then next step, the same as what we did here on line number 295, right? Basically, we just create a new array and copy things over. Done. So once we know the business layer, we know what service we are providing. We know the differences. We know what the problem is. solving is very quick, right? And so far, you see that most of the code from copy constructor was copy to move constructor and copy to assignment operator. You just have to copy the right portion of the code, right? And that is done for the copy assignment operator. So the next thing, if we use an L value for copy assignment operator, right? Then for the move assignment operator, we use an R value. That's the only difference, right? And whenever we hear R value now, it's a good news because look at this. If it's an R value, we don't need to write any lengthy code. All we need is a swap. We are done. That's it. We write the same if statement. We take care of the three easy uh, parameters the same way, and we call a swap, and that's it. And again, in this case, right, we are given on the right side of the equal operator of the assignment operator, right? We got an R value object that has a bookshelf, right? And we on the left side we have an existing object that also has a bookshelf. Are we all good here? So now what is the story here? This object is soon to be destroyed, the R object, right? We just need to detach that bookshelf. We also detach the bookshelf on the left side. And then we say, now I own this one. And this one is gone as well. Everything is gone, right? Only the one student and one bookshelf left for for the result. That's it. Very neat, very clean, and very fast, right? And you did not have to write any new code at all. Exact code, everybody, and you just copy from the previous big five. That's it. The exact swap from here. All right. So now next thing, destructor is number 5. Whenever we write the destructor, make sure that we start with this tilde. That's what they call, right? This operator here, we call that the tilde. And then we put that right in front of the class name, taking no argument, void, right? Do we have a group named void? I think I saw a team named void, right? C++ void or something. And then in the destructor, right? The most important part, where the problem? We get back to the constructor, right? Item number 0. The problem is on line number 268. The problem is the bookshelf. And when we clean up, we have to make sure that we take care of that area 3, right? Bookshelf. Otherwise, we're going to have memory leak right there. So we want to delete that bookshelf in the destructor. That's why we call the delete. In order to do the proper deallocation, from package number 3 and from midterm exam, right? We want to delete that bookshelf, and after that, we want to know the pointer to do the proper, deallocation of that bookshelf. And we cannot assume that there's always a bookshelf, right? We don't want to get into the situation when we have a dangling pointer and we delete an object that is not there. So make sure whenever we call delete, we put that in an if statement so that we are not deleting, a non-existing object. Are we all good, right? Okay. So there we go. We are not going to need it when using smart pointers, so that's good news. Sorry, Jay, that is not true. In order to work with smart pointers, right, you still have to write all of this yourself. You still have to do. And then you got to set up the smart pointer. Yeah. The smart pointer doesn't do everything for us. It doesn't. Okay, it doesn't. Okay, so now the rest of the page here is the same code, right? The same exact code, that we used earlier. I want to move on to the demonstration and especially reading the code of the demo for you. So I want to give you about 5 seconds. Please look at the implementation, right, to see if you have any question, to see, any portion of code that you want to pay more attention to in the demo to see exactly how it works, right? Because running the program, seeing the output, going to help us understand the code as well. So about 5 seconds, and then let's read let's do the demo together. Okay. Any questions here? Any questions here? For the variable books, it is unclear if it's a string, a vector, or an array until the constructor. That is correct, Joel. That's what we talked about last week on line number, and that's what we really have to pay attention to in C++. People make mistake there all the time. On line number 112, Joel. Okay, and the constructor was provided on line number 81. Okay. 81, 112. And that is a problem throughout the whole, the whole experiment. Yeah, very good question there. You got it, Joel. You got it. Okay. Any other question? Right. All right. Are we ready for the demo, everyone? Are we ready? Ready? Okay. So this demo very interesting. Okay, but it's not easy to understand. So please follow me. I'm gonna start with two easy ones, and then we're gonna go into great detail right away. All right. So two easy ones. The first one, right? On line number 387, everybody. What are we testing? Just by looking at the code. What are we testing, everybody? We are testing the copy constructor. Very good, Harry. Everybody's good. How do we know it's a copy constructor? Because we are calling the constructor using an L value existing object from the previous line. Everybody's good now, right? So this is a constructor that we created, not the constructor that given to us by default. So now let's see what's going on. The same exact code that we wrote for the demonstration earlier that did not work. Okay, and we see that on line number 395 and 396 right now, Mickey is reading C++ and Minnie is reading Java, so it works, right? Our implementation works, and it works because of what, everyone? If you need to explain why it works for this simple first easy one, it works because we had a complete deep copy, right? We did not have a mixed copy, right? We use a new keyword to create a separate bookshelf for the new student. There's no shallow copy for the bookshelf, and that's why it works. Mickey has his own bookshelf, and Minnie has her own bookshelf in this case. Okay. So for the second test, right? On line number 403, what are we testing, everybody? On line number 403, what are we testing? Just by looking at the code. On line number 403, what are we testing? We are testing the copy assignment what? Operator, right? We are testing the copy, and this is right here. And why is it a copy assignment operator? On the right side, right? On the right side, we have an L value object. And that's what it is. That's why we are invoking the copy assignment operator. The problem last time was what? On line number 411, when we ask Goofy to read Scala, right? We end up having both Mickey and Minnie reading Scala at the same time for the second object. But no, over here now is perfect. It works for us, right? And again, the answer is because of what, everybody? This is still a simple one. The answer why it works because those are their independent bookshelf, right? We create a new bookshelf for each student. Everyone's good. All right. So now let's get interesting here after this warm up. On line number 433, what are we testing, please, everybody? 433. If we look at this code here, do we know what we are testing? On line number 423. Thank you, Kevin. 423, what are we testing? We are testing the move constructor. Very good, right? And why is that a move constructor? Let's look at the preparation, the setup for this experiment. On line number 420, we say this. I'm going to create a student, and I call that student student temp 01, right? And then I see out the location of that student, and most importantly, I see out the location of the bookshelf of that student. So what we see here, number one, the student that I just create, right, is currently at what location? Is at 380. And the bookshelf, what we want to pay attention to is at 40C. And after that, we say, I'm going to create Sylvester. And Sylvester is our new student, right? So Sylvester is a new student. And I'm creating Sylvester using student temp. And student temp is an L value object. In order to pass in an R value object, I use move to convert that object into an R object, right? R value object. So if I receive an R value object, that means I'm invoking the move constructor. Everyone's good here, everyone? Everyone's good here? Yes? Are we all good here? So now what's the result of it? The result of it is this. We are saying, well, after I create Sylvester, I check the bookshelf of student temp. And look at that. The bookshelf of student temp is gone. It was detached. It was detached from the student. It was taken away from the student. So where is it now? Where is it now? It was given to Sylvester. Sylvester took it, everybody. Sylvester took that bookshelf. Right? Sylvester took that bookshelf. Sylvester never created a new bookshelf. Just took the bookshelf from the student. So now what really happened in the back here? First of all, we want to check to make sure that Sylvester is not that student, right? We're very important. We don't want to assume anything. On line number 427, we output the address of Sylvester. So Sylvester is not that same temp student. Very good. But Sylvester now is owning the bookshelf of that student. And then Sylvester's name as a successful deep copy is student temps 01, right? The number of recommended book is 7. So now this is a chance for us to test the destructor. The destructor is invoked in two situations. Number one, out of scope, or number two, we call a delete ourselves, right? So I want to demo the both two situations for you. So here we go. I make a manual call to delete the object, right? So we learned that this student temp, does not have the bookshelf anymore, right? So if the destructor saying that is creating the book is deleting the bookshelf, we fail, right? But if not, then we succeeded. And that's not what we see in the code here. We want to look at the output. But before we look at the output, we want to make sure that we did the proper deallocation here. We say student temp equal to no pointer. Everybody understand the service layer here before we look at the, in depth into the output on the next page? Any questions so far? On line number 419 to line number 431. Any question? If you don't have question, give me some confirmation, please. Okay, question, Harry, please.
Yeah, so on line 431, since student temp 01 is going to be in activation record, right?
No.
It's not, because, wait.
The student object was created on line number 240. There was a new keyword. So where's the object?
No, but the pointer is gonna point in area 3, but it's gonna stay itself in area 2, or is it both in area 3?
In area 2 and in what activation record, Harry?
In the last one, in the main one.
That's right.
Yeah.
Yeah.
So why do we need to point it to null pointer if it's gonna pop, if the activation record is gonna pop out?
We still have work to do here, right? And during this time here, do you want to access it and crash your program?
Oh, makes sense.
Right?
Yeah.
So we have to clean it right away.
Yeah.
Does it make sense now?
Thanks. Yeah.
Yeah. Okay. That was a very good question, everybody. The reason for us to know any pointer when we don't use it anymore. It's not about whether it will be cleaned up later or not. If we like to work with that system, then we go back to Java, right? Okay, we leave garbage everywhere and just hope that Java are gonna do the right thing and gonna clean it for us. And just hope that we will never accidentally use the garbage, right? Or try to use a dangling pointer. And that is not what C plus plus about. C plus about very accurate execution, and you take control of every single bit of memory. Okay, every line of code that you write. Did I answer a quick question, Harry? Are we all good here? Yeah. Any other questions? All right, wonderful. Thank you. So now let's look at the code of test number 3 together, everybody. Look at this. Do we understand what's going on here? Do we understand what's going on here? The test that we just did together, right? We invoke the move constructor right here on line number 467, right? Before we invoke the move constructor, we create the student temp. Here we go. We create student temp. In order to create student temp, we invoke the constructor for that student object, right? And we put that student object, at memory 380, and the bookshelf of that student is at 0C, right? And then we call the move constructor, and the move constructor took the student's bookshelf away. That's why the bookshelf's address is 000. And that it was taken away, but it wasn't destroyed, right? It was given to Sylvester. It was given to Sylvester. And now Sylvester owning the object, but Sylvester himself is at a different memory location. And still Sylvester's name as copy from the temp student is student temp 01. And also the number of recommended book was copied. And now we call the destructor. When did we call the destructor, everybody? Wait, what line number, please? What line number did we call the destructor on the object? 430, right? I want to make sure I write the line number here for you. Thank you, Kevin, so that our classmate can review when they need to. So you want to write 430 here, right? So now what's important in this destructor call is that number one, right? Related to the question that Harry just asked, right? We delete this object before it went out of scope, right? We delete this object, right in the middle of the execution of the duration time of the main function call, right? So we delete this object here, and we know that every student object owns a bookshelf. However, we did not delete the bookshelf here. And why is that, everybody? Right? Remember when we wrote the destructor, we had a statement to delete the bookshelf, right? But how come here we only we say we only accessing the object, but we did not delete the bookshelf, everybody? Why is that? Why there was no? That's right, because Sylvester took it. The bookshelf is remaining right here. Sylvester took it, right? We want to detach it and we want to give it to Sylvester. So there's no bookshelf right here. That's why there's no deletion. There's no bookshelf here. There's no deletion. Okay, no books. All right, are we all good with this? Any question, everybody? Any question? It's a little bit quiet. I hope you're taking note. That's what it is. Okay. After taking note, can you give me a confirmation before we move on to the next one? Next one is more complicated, and we need this one to understand the next one, right? So how many confirmation am I getting? So I want to know your understanding. Okay. A dot, a green dot, any signal you can give me, everybody. Oh, good. Oh, awesome. Okay. All right. If you have a red dot to give me, I would love that too. Okay. I will explain the problem again. Okay. So now let's move on to the next one. Stop me right away. Okay. Just like Tony and Harry and Jay, everybody who are doing very good here. Stop me right away when you don't understand. I'm going to explain the next one. And the next one is pretty tough, right? So here we go. But it's beautiful. You will see how beautiful it is. All right. The next one. What are we testing, everybody? What we are testing next? We are testing a move assignment, right? Operator, right? Move assignment operator. That is online number 436, right? Everything we learned so far, from package number 1 to package number 8. The package that we are reading is package 7, but we finished package number 8. Everything, okay, is put together in this one line, 436. That's what it is. If you look at line number 436, you know what's going on. You are doing well. Why is that? Right? So 436, that's everything's in there. So what did we do to set up for this experiment? On line number 434, we create a student named Jerry, everybody. So Jerry is an L value. Jerry is an existing student. Jerry has named Jerry, and the number of books that Jerry is recommended to read is 11. So we say, where's Jerry's bookshelf? Sorry. Jerry's bookshelf is at 504. Okay. Now we start. We say, well, Jerry, I'm going to override you using an R value. Here we go. So on the right side, we are creating an R value object, right? No name, anonymous object on the right side. Okay. And we want to use that object to override Jerry. So after we did that operation, we got outputs, right? We got outputs here. In the output, we see that Jerry's bookshelf now is a new bookshelf. It's a new bookshelf at 774. It's not Jerry's no bookshelf anymore. Should we be worried here? Right? Seems like we want to. There might be a problem here. And then Jerry's address, right, is D84. That is the address of Jerry. And recommended books now is 3. What happened? Was it successful or not? Right? What happened? We don't know, huh? We don't know. So now let's look at the output. Look at the code together on the next page. You see what we did. So we said, wow, look at all of this, everybody. We said, we call the move assignment operator, right? We call the move assignment operator. Why so much happen? Why so much happen here? We remember that before we call the constructor to create Jerry, right? After we call, we just output the value of Jerry. So line number 481 to 485, where did they come from? Where did they come from? What happening? Is it correct or not? Who can help the class understand here? Let's take about 5 to 10 seconds, everyone. Who can explain what's happening? What is happening here? Why we got so many outputs? Why we got so many outputs? Who has an explanation? Who understood everything from package number 1 to package number 8? Maybe in the fall, starting the fall semester, I should prepare a bunch of sound effect, right? For example, when you're thinking, I can play the TikTok, the clock sound. When someone answer a good question, I can play the clapping sound, like a DJ for you. Joel, there is a destructor in the move assignment operator function. There is a destructor in the move assignment operator. Sorry, no. There's a relationship, Joel, but there's not a destructor in the move assignment. Those big five work together, but they are not part of each other. They are independent. Harry, something is with the swap, I guess. Oh yeah, everything with the swap. Actually, everything with the swap, because we are trying to apply the right swap, right? Right. So we have three choices. We have number one, copy semantic. We have the swap using move one, and we are having the swap using move number two. And our goal is to achieve the best. That is swap number two, right? So did we succeed? That's the question here. 2 more seconds, everyone. Who can get this one? 2 more seconds. Line number 436 is the one invoking all of this. That is correct, Kevin, right? Right or not? Yes, but why? Kevin is very good here. Who want to work with Kevin and get the explanation here? That is correct. Okay. All of this, everyone, came from line number 436. Let me write the line number here for our classmate so everybody can use it. And let me copy that line over to this side for you, okay? So everybody can learn this important line as a recap of what has been happening. So let me write this line on here for us. It's say Jerry equal to student um, student temp 02. Oh, I got a new pen for my computer too, everybody. Doesn't work as well as the iPad pen, but pretty good when I need to use my computer. Okay, so that is one line 436. Okay, who can explain this? Looks like it's sort of mixing everything we did so far. Yes, that is correct, Kevin. Well, yeah, line number 436 calls move assignment operator, doesn't it? That's right, Harry. Alfonso, we are creating a temp object and then swap it with Jerry and then destroy the object. 90% there, Alfonso. 90% there. Very good. So our classmate Alfonso point out the three important steps. And we talk about those three important steps. We talk about those. When we analyze three ways to create the string CSC 340, hello CSC 340, we talk about this right at the beginning of package number 6, right? This is just a bigger example, right? A deeper look, and we implement everything ourselves. That's what it is. Harry say, and then I think swap on line number 328. Call other 328. What is 328? 328. 328 is a getter, Harry. It's a getter. So
Oh, that's 428.
Oh, 428. Oh, sorry. 328. 328. 328. The swap. Yes, this swap is as the back of the move assignment operator. That is correct too, Harry. Very good, right? Okay, so you actually worked together and got the answer already, everybody. if you put together, all the observations that our classmate share with us, right? So can I explain this one time for us? Anybody need an explanation, or we just move on? Can I recap this? What happening? Anybody? Should we? Yeah? Okay. All right. So now let's do it. Yeah? All right. Ready? What happened is this. Remember that on line number 436, right? That one line that, summarized most of everything in the last 8 packages for us. 436. So online number 436, as Kevin, Alfonso, Harry, our classmates are trying here, and those who Joel and those who are trying but not texting, right? What we see here is this. Number one, let's make sure that we match it, right? When we create Jerry on the left side, that was when we invoked the copy constructor, right? And then we say, okay, I want to check, where's Jerry's bookshelf. Everybody's good with this? Yeah? Are we all good? And then, we got to create the temporary object on the right side, right? We got to create the temporary object on the right side before we can use it. It doesn't exist. That's what it means by temporary object. And that was on line number 481. So we create, that's why we are calling line number 481. 481. We create the object. Okay. After we create the object on the right side, we said, I'm going to copy this object, to the left side to override Jerry, right? Everyone's good here? And the object on the right side here has a bookshelf, right? The object on the right side here has a bookshelf. So now we invoke the move assignment operator, and it does its job. And then after it does its job, it goes away, right? Because it's an R value, everyone. It's an R value. Since it goes away, the destructor was called. What does the destructor do? The destructor said, I'm attempting to delete, this object at this memory location. So this memory location right here is the ending AB4. Are we all good? I'm trying to delete this object right here. So, okay. And it says that, it actually has a bookshelf. So I'm going to delete the bookshelf. Okay. Right? It's not no, that means it has a bookshelf. So I'm going to delete the bookshelf. I'm going to delete a bookshelf. Right? And then we say, okay, on line number 486, where is Jerry's bookshelf now? We say Jerry's bookshelf is 774. So here's a problem, right? Here's a problem. And this is where we need it, everybody. We need to pay attention here. This bookshelf here is 504, right? And so far, there are only two bookshelves in this picture. So this bookshelf here has to be ending 774, right? 774 ending here. If we deleted it, right, how can line number 486, Jerry still having that bookshelf? Who can answer this question here? On line number 486, right? If we deleted it, how come we still have the bookshelf on line number 486? Who can answer these questions here? That's right, Kevin. What happened is on line number 482, right? Invoked by number 436 again. This important line. This line here, right? This line here swapping, right? It's swap already. It's a, the right now, right? Unlike this line here, it says that this bookshelf over here is actually the one from 504. Are we all good? And we already swap it, right? We already swap it out with the one from from Jerry, right? So in order to give you a better picture, I don't want to move objects around, okay? I want to keep them where they are. So on the very top here, everybody, let me explain, clearly and slowly for everyone. All right, right there. This is the bookshelf of Jerry, right? This is a bookshelf of Jerry that we created before we start the demonstration. And this is at 5:04, right? This is at ending 5:04. Online number 482, online number 482, right? The effect of 482, and 482 is actually 436. Let me give you a purple color, right, to make it easier to recognize here in this case. So over here, online number 482, which is 436, right? We did this swap here. We are swapping this bookshelf with this bookshelf. And what we mean by swapping is we are not physically, swapping exchanging the memory location of the two objects. What we did was this. What we actually do is that we have the pointer here pointing at this bookshelf. And this pointer here is pointing at this bookshelf. Everybody's good, right? Let me erase all the lines that are not necessary here to keep the picture clean for you, okay? And you can understand it better. So here we go. All that happened is this. That's it. So now we have, Jerry, right? Jerry is owning the bookshelf down here. And the temporary object is owning the bookshelf up here. And now, when we delete the temporary object, we actually deleting this one and deleting this one. And we are keeping Jerry and the object down here. That's why Jerry is owning, 774. Everyone's good here? Everyone's good? Isn't this beautiful? We move the pointers around. We never destroy the object. We never have to take any books out from the bookshelf to do any movement at all. Right? This is beautiful. And Kevin called that traumatizing, right? When I was a student, I learned this, and I did not need to have dinner. It was so great. I enjoyed it. Did not need dinner at all. Okay. I hope you enjoy this, everybody. Do we all understand now? Do we all understand? Does anybody need me to explain again? Yes? A big yes? Can I have more confirmation here? Are we all good? This is cool, right? If you say this is cool, you can move on to smart pointer. And that is the last topic we need to finish assignment 3, right? Question, go ahead, Harry. What question you have, please?
I'm sorry, but wait, who called the destructor on line 483? Did the swap call the destructor?
Who calls the destructor on line number 483, everybody? Who called the destructor on line number 483? Who called it?
I'm confused.
You're not. You're asking the question means you're thinking. You're thinking, you can follow, what is not making sense. That's why you asked a good question. That's right. Line number 436. Very good,
Okay.
William. Line number 436. I wrote it here, and let me go back, here so you can see it better. Remember, I talk about what? The parameter scope, right?
Mhm.
The parameter scope, right? That's all it is. So we pass this object, this R value object, to what? To the move assignment, right? Move assignment operator. We use it for a moment, and after that, it's gone. So the move assignment operator that we call on line number 436, call delete on the object. That's it. Are we all good now? Because it's out of, this is not because it was inside the move assignment operator. This is because it is not used anymore. So be very careful with this point here. I think Joel or somebody earlier asked about this. It's not a part of the code. It's just the fact that you create an R value object and you don't use it anymore. So it's get destroyed. And that's what we've been learning in package number 5, right? Yes.
Okay, so that's what move assignment operator does. That's how it works. That it automatically calls the destructor by itself.
Oh yeah, move mean you are using a temporary object, and the
Even
temporary
if
object
yeah,
means it will be destroyed.
yeah, even if the destructor is user defined, it's gonna call. How does it know like which destructor to call
Every class has one destructor,
that
right?
we create?
We can create, or the system give us that may not work. That's what
Mm.
we learned last last week, and I recap for us before the class. Remember, right?
Okay, cool. Yeah,
And the definition of temporary object was what we went through, very thoroughly in package number 5, right? We learn again and again what it means by a temporary object. An object with no name, an
yeah,
object that we create for a moment. There's no identity, there's no attachment, and it's gone, right?
yeah.
After
I
that,
knew
it's
like
gone.
it's gone, but I didn't know like the destructor does the work for us. Like the user defined destructor does the work.
No. The destructor does not do the work. The destructor only get called to do the work. Be very careful here, right? The destructor, and how the destructor get called. Again, the definition from the last week package, right? This is why we need a lot of time to learn things again and again. And I understand that summer, we don't have much time. On line number 212, right? Remember, I wrote all of this for us, right? When is the destructor invoked, right? Two scenarios: out of scope, or it is, subject to a manual delete. Out of scope means out of, area 2 or 4B. Subject to
Mhm.
a manual delete mean is deleted from area 3. We can only call a manual delete on a new, and a new has to be from area 3,
Yeah,
right? All the dots connect here.
yeah. Oh, makes sense. Yeah,
Oh, great.
makes a lot of
Awesome.
sense.
I
Yes.
know. It's good. This is why I did not have dinner that day when I learned this in school.
That's cool.
I had C++ for dinner. All
Thanks.
right. The next thing, going to give you more about the destructor. Okay, the next one. Remember when we work with the default destructor, right? After line number 443, right? We say at the end of the program, there was nothing there. That was totally empty. But look at this. If you continue our demo, after the end of the program, what happened here? This is a real destructor at work, everybody. Look at that. How beautiful. You see that in Java, you never see any of this, right? In Java, you never see anything happening. But in C++, and we just create the destructor ourselves. After the end of the program, the destructor wakes up and delete all the leftover right at that point. We don't have to wait, right? This is almost on demand here. We did some on demand right here, right? We have the destructor call ourselves, right? In test number 3 and 4. And here, kind of in demand and more kind of automatic, but we set that up. At the end of the program, the destructor wakes up to delete how many objects? 1, 2, 3, 4, and 5. And that's all. All the objects that we created, right? All the temporary object already deleted before the end of the program. And now at the end of the program means what? Everybody, can just somebody define what it means by end of the program? End of the program means what? Anyone? End of program means what? In the context of our class, right? What we are discussing, end of program means what? Means of we are emptying the memory, we are returning 0, we are emptying the stack, we are destroying all the object. End of the program means return 0. End of the program means end of main. End of main means we are popping the activation record of the main. That means all the objects, right, that we've been using for that main should go out of scope. Are we all good, right? And in this case here, we are taking object out of scope, and also we are cleaning all the pointers ourselves. And that take care of area 3 as well. Very clean, right? Very clean. So now let's more observation. More observation. 493 to 507. Is there anything else we can learn from here? Anyone has a good observation on this? 493 to 507. Any other observation you can make here? Eyes for details, laser focus. What do you see? It's LIFO. Thank you, Kevin. Wow. It's LIFO. And why is it LIFO? Right? Why is it LIFO, everyone? Let me give you the lice number first, right? If we delete the object at 484 and that object's name is student 1002, right? Then that was actually who? Who was that? That was from the object was created on line number 434, and that was actually Jerry, right? Because Jerry copies the name of the temp student. And then this one here is on line number 420, right? And that is Mr. Sylvester. Are we good? And the next one is Mr. Goofy. Yeah. Mr. Goofy is on line number 402, right? Very goofy. 402. And the next one is Miss Minnie, 387 Minnie, right? And the next one is 386, right? The boss. The boss, the very first one. You can only get rid of the boss after you take care of all the subordinates, right? So think of this, as Calvin said, we have to follow the LIFO. Whenever we in computer science, if we want to take out a parent process, we have to take out all the dependent processes first. We have to take out all the dependencies yet. Or think about cutting down a tree. If you want to cut down a tree, you want to start out taking off the branches first. Everyone's good, right? We cannot just take the main the body of the tree down. Is that because it's a stack? It can be managed in any fashion, actually, right? It can be a linked list, it can be a map. It really depends on how you design, your process managing system. But you can think of stack to explain it. And the keyword here is dependencies. You got to take off the dependencies before you take off the parent process. Okay. It can be anything, but it's always be LIFO. Think of it as LIFO, but don't make it have to be a stack, right? A stack is a data structure, but we know that for any other data structure, we can always enforce certain rules on it, right? We can make the rules ourselves. So we don't need to have a bottle in order to contain water. Okay, you can always put in a bucket as well, right? All right. I hope you enjoyed this, everybody. And that was the end of package number 7. We are done with 7. We are done with 8. Any last question for me before we get into smart pointer? I wanted to finish more smart pointer, but I really always enjoy giving more thorough explanation to all of us. Strong foundation is important, so it's okay. We are going a little bit slow here, but we're gonna get it done. We will be done with smart pointer this week, right? So you have everything to do the assignment way before it's due. So we are done with 7, everyone. We are moving on 9. All right. So everybody, so it's all done for the 3 section here. So we now can move on to package 9. Um, are we getting help from Isaac here, getting package number 9? All right. So let's move on package number 9. All right. Package number 9. Who's ready for package number 9? Very important topic. Thank you, Isaac. All right. So package number 9 for tick section. Okay. Welcome to a new day. Package number 9. What is package number 9 about? All right. Modern C++, smart pointers, automatic memory management. Why did I put automatic in double quotes? Anybody understand why? We are not ahead, Isaac. We are actually behind, because this is the first class, right? For this, we are on Monday, right? So and other classes, they already finished package number 7 and 8 last week, so they're gonna start with package 9 right away. So they are about 1 hour 45 minutes ahead of us. Okay, but no problem, no problem. Just learn things well, no problem at all. So the reason for me to put the keyword automatic memory management in double quote is this, everyone. We are learning a very powerful tool, right? We talk about dangling pointer, we talk about double delete, we talk about managing, thousands of pointer, right? We talk about memory leak, we talk about object in and out of scope, we talk about new and delete, right? There has been a lot of things that we talk about. We talk about pointers to pointer. In the last example, a big five, right? In the last example, big five, we talk about a very simple situation, everybody. We have an object, and that object on a bookshelf, right? That was a situation that we deal with last package, and that there was a lot that we need to do in order to take care of that situation. In reality, that's not that simple, right? You're gonna have objects that own objects, that own objects, right? That own several objects, that owns other objects, and they go around and around and around. How are you going to write a big five to manage all of this, right? And for each of those objects, you can have pointers from everywhere. We are not talking about one or two pointers. We are talking about thousands of pointers, and maybe pointers to pointer. Then how are you going to take care of this problem? This is where many C++, programmer actually gave up, right? So now, smart pointer is a very powerful tool that gonna help us take care of this situation. Yeah. However, it's not done, automatically. That's why I put the keyword automatic in, double quote. We call that automatic, but it's not, because it only works for us if we set it up correctly. In order to set it up correctly, we have to understand inside out how it works. And most importantly, again, we need to understand the situation we are in. We need to know that the problem was a bookshelf. The problem was we have many more. And then we have to know this is what I need in order to, what kind of mission, what kind of problem I have, right? And then this is what I need to do in order to get to the goal, right? And now, instead of doing that myself, instead of applying the swap number 2 instead of swap number 1, and absolutely not copy, right? I have to have a way to set up the pointers properly in order for that to work. If we don't set up the pointers, the smart pointer properly, everybody, we end up wasting, more than twice as much of memory that we actually can lose without smart pointer. And memory optimization can be a lot worse, right? We are talking about crashing here. Okay, so in order to use powerful tools, we need powerful, we need to have the power. All right, so let's get that power. How do I give you that power? Um, Smart pointer is a pretty big story. As a story start, let's say smart pointer was included in C++ on I would say about August 2011. Yeah, about August 2011. If my memory still work, so that means C++11. Okay, and it was available all the way back to 2000 actually, right? And it expected to be included in 2010. It was late, that's why it available in C++11. So make sure that we, oh yeah, it's brand new, William. It's not even a standard for many companies. So you are learning something that you're going to apply when you graduate. That's where the value comes from. That's why if we don't learn Big Five, if we don't learn Smart Pointer and other topics that I'm giving you toward the end of the semester, then it's just pointless, right? It's just pointless. If we did not learn Big Five, then C++ class has nothing more interesting than Java, right? But we saw how interesting it was today. Um, so when you want to experiment with smart pointer, everybody, okay, make sure that uh, pointless or no pointer. No pointer is actually a memory address, Joel. Pointless means there's no memory address at all. So when we want to experiment with smart pointer, make sure that we get the latest version of C++. Okay, everybody, the compiler. All right, update our ID and everything, and I will explain in detail. So back in 2010 and before that, everyone, the place where I work, right, we got exposed to smart pointer, and we were anxious. We did not know if we should use it or not. So they created a task force, yeah, and I was a part of the team. Was just to convert some of the program that we were having into smart pointer version and see how it worked. See if it was possible to integrate with the rest of the system, and if it was possible to deploy to client side. It was huge. Everybody was anxious. I would say nervous, right? So for our assignment three, right? There's one question where I ask you to convert, the linked list that we learned all the way from 220. We're gonna learn the C++ version of it, and we're gonna try to convert that into, the smart pointer version. I made the requirement of the assignment, doable to everybody. But if you really wanna achieve smart pointer, right? But if you really want to achieve smart pointer, you want to take everything from package number 9, right, and apply that in assignment 3, and that you prepare for the job. So that's correct, Jay. It is a small assignment, but you can make it as big as you want. Okay, and that's how you can prepare yourself for job. If you just aim to get the assignment done, it's very little to get that assignment done. But if you really aim to learn and apply everything we learned from the package, there's a lot you can do with assignment 3, right? So now, even now, if you go out there and pick up a book in C++, everybody, I would say if you're lucky enough, you find one or two books that explain well about smart pointers. One or two books, right? And those two books either came from Scott Meyer, right? My favorite writer here. I'm not selling his books. I just want to share with you. So Scott Meyer is my favorite man. I went to many conferences where he talked. You know, I got all of his books and following his news all the time. The creator of C++ actually did not write well on this topic. How strange is that is? And on this line number 3 and 4, what I did was this, everybody. I actually share with you a chapter of Scott Meyer's books on smart pointers on the file manager. You can read it for yourself. However, it may sound like Greek for you because they use a lot of advanced concept and terminology. So in this package number 9, what I did is this: I combined all the books from all those writers, right? From there, I went to the C++ conference, and from their article, presentation, and all of this, and I put them as much in layman terms as possible for us to learn, right? So that's this package is about. I put everything in layman term for you, and of course, we're gonna learn new concept as well. Okay. So number 6, online number 6. Why do we need to learn smart pointer? So I just gave you the picture, right? If you don't want to quit C++ at one point, you want to learn the smart pointer. The reason why, right, people tend to make mistake in C++, right, is right here. From line number 8 to line number 31, right? Let's mark this together, okay? Then we may continue next time, but I want to give you some explanation to inspire you to start reading, rather than just leaving you, doing it yourself. So line number 8 to line number 30, you can name them as the common mistakes that programmers make with memory management and memory optimization. And that is the reason why we need smart pointer. On line number 32 to 40, on line number 32 to 40, what I gave you on line number 32 to 40 is that those are the most basic rules when we deal with, smart pointer, right? So on the top here, let me write here for you too, just in case you can follow. So common mistake, right? Common mistake. Common mistakes is up here, and over here is basic rules, right? Basic rules that we need to follow in order to do smart pointer. And then at the bottom here, when we understand the topics, right, I give you from line number 42 to 49 when to use smart pointers, right? Strictly, right? As a programmer, you ask the question when you want to use smart pointer. When you know the reason to use smart pointer, when you know when to use smart pointer, and then that is the time when you master the topic. And you want to ask the question when not to use smart pointer, right? When not to use smart pointer. Because if you open any books, right, the first thing they're going to tell you is that it's safe to use smart pointer anywhere you want, right? Whenever you have a question whether to use it or not, you want to use it. But it's not entirely true. It's true that the Ferrari, right, can take you anywhere, can take you to SF State, right? But if you live about 10 blocks away, you want to take a bicycle. So you don't have to worry about your car when you're in the class. The chance is that, after class, you go out and then you don't see your car anymore. Are we all good, right? So smart pointer is great, but it's very, very expensive. And it's not easy to set up for it to work properly. That's why I gave you line number 50 until the end of this, page on line number 58. On Wednesday, right, we're going to start the class and we're going to learn smart pointer and we're going to finish this package. Okay, so you have everything done on Wednesday for assignment 3. Are we all good now? All right, welcome to week number 8, right? I hope you make a lot of progress with your team and with the assignment and with the material. I will see you on Wednesday. Thank you, everybody. Thank you so much. See you on Wednesday. Thank you. Thank you.